Hello, welcome everyone, welcome back to my channel, and today we are continuing with the circle theorems, and this is the last circle theorem that we are doing. And to be honest, this is most misunderstood theorem in circle theorems, and this is alternate segment theorem, a theorem many students find challenging. Well, let's take some time today to break it down clearly and understand it step by step. So this one you can clearly see as the diagram of the alternate segment theorem, but before that I'm running GCSE booster classes, crash course classes at just £4 per hour, and the regular classes at £6 per hour. Or if you're looking for any subject from year 1 to A levels, they're highly affordable. Just to book a free demo for any of these classes, just drop us an email at exactadmit@gmail.com. Or if you're looking for the mock papers, they are also helpful for your progress, or obviously if you're struggling, we are providing the last minute material, the flashcards, everything. Also from 22nd April we are starting the test series. So if you want to book, if you want to purchase anything, you just need to drop us an email at exactadmit@gmail.com. And if you're looking for the free written materials, free theory materials, and free worksheets like those questions that we are doing here on YouTube, they are available on our website, which is www.exactadmit.com. So let me continue with this. Well, this alternate segment theorem says the angle that lies between the tangent and a chord is equal to the angle subtended by the same chord in the alternate segment, which means this is our chord. That is, this is the chord. Important part is a chord divides a circle into two different segments. This chord has divided this circle into two segments. This is the first segment. Clearly you can see this one, and this is the smaller one, so this is called the minor segment. Now the same chord has divided circle into other part, this one, and this is your major segment. So segment, you can clearly see, is the part of the area of the circle that is bounded by the chord and an arc. So now this chord and a tangent is making an angle. This chord and this tangent is making an angle, this one. Now this angle is equal to the angle which is an alternate segment, because this chord is making an angle with this tangent, this angle. Now this is first segment, as I told you, like the minor segment. This is the second segment, that is your major segment or alternate segment. So this chord is now making an angle at alternate segment, because this chord, we know that angle subtends an angle, this chord makes an angle. So this chord makes an angle, that means this chord can make angle here, can make angle here. So in this case, this chord is making an angle here. So this angle and this angle, they are always equal to each other, and that's the meaning of alternate segment theorem. Well, let me understand its proof. So for the proof, there's a basic difference. What I did, there is a center, so we have just connected both the vertices to the center so that we can understand its proof. Now if you see this one, we're talking about we have to prove angle BC, and let me just name this L. Let me just name it here. Let's say this is small l. Let me just name it here. So if I'm saying angle BCL, that means this L I'm talking about, this one. So angle BCL is equals to Y. Let's say like this one be Y. So what we are trying to prove? We are trying to prove that angle BCL should be equals to this angle, which is angle BAC. We have to prove these two equal. So for that, what we did, let me join BO and OC. Now BO is equals to OC is equals to R because they both are radius, which makes triangle, therefore triangle BOC is an isosceles triangle. So triangle BOC is now isosceles. That means angle OBC is equals to angle BCO. So these two, OBC, that means this angle, and BCO, that means this angle, because obviously this whole triangle is now an isosceles triangle. And if this whole triangle is an isosceles triangle and OB is equals to OC, that means opposite angles should be equal, which is this one. This angle is equals to this angle, and same thing we have written here. Now in this triangle, if I'll apply angle sum property, so applying angle sum property in triangle BOC, so in triangle BOC, on applying, I'll be writing, so in triangle BOC, this angle plus this angle plus this angle should add up to 180 degrees. So the same thing we are doing here. So I can say triangle and angle, so let's say angle B plus angle O plus angle C should be equals to 180 degrees. Now one thing we know by the previous theorem, that was like a tangent theorem, it says that the angle between the radius and tangent is always 90 degrees. That means clearly this is what? This is a radius. Any straight line that connects the center to the circumference to a point on the circumference is radius. And this is clearly a tangent, a straight line that touches the circle at one point. So angle between them will be 90 degrees. Now, because let me say we have assumed that this to be y at the beginning. So if this is y, this whole is 90 degrees. So clearly this angle is going to be 90 minus y, obviously. So same thing we'll be writing here is that angle OCL is 90 degrees. Angle OCL is 90 degrees because angle between tangent and radius is always 90 degrees. I'm not writing the entire theorem right here, but obviously you have to write it here. I'm just explaining it and it will take more time for me to write it down, so I'm just leaving as it is. So this is 90 degrees, and if angle BCL, so let angle BCL be y, then this angle, this remaining smaller part, which is angle BCO, then angle BCO will be 90 minus y. Because angle BCO is equals to angle OBC, that means angle BCO is equals to angle OBC is equals to 90 minus y. And now applying this, coming back to this one, I'll be saying that in triangle BOC, 90 minus y plus 90 minus y plus angle O is equals to 180 degrees. That means angle O is equals to 2y. And if this is 2y, this is 2y, I'm again repeating because this whole is 90 degrees and this is smaller is y. So that's the reason this comes out to be 90 minus y, because we know that OC is equals to OB because they both are radius. So the opposite angle will be equal. So if this is 90 minus y, this will also be 90 minus y. And now applying angle sum property in this triangle, that means sum of all the angles of a triangle equals 180. So adding this and subtracting from 180, I can calculate this one, which is 2y. Now clearly if this is 2y, this is y by our first circle theorem, which says angle at the center is always twice at the circumference. That means at center is 2y, so for the circumference it's going to be half of it. So if this is 2y, then angle BAC is equals to, so angle BAC is equals to 2y over 2, which is y, by angle at the center theorem. And you have to write the entire theorem, which says angle at the center is always twice at the circumference obtained by an arc, is twice at circumference. And hence we have proved that angle BAC is equals to angle BCL, that we were supposed to prove. Angle BAC is equals to angle BCL. That's your alternate segment theorem. Now let me do one question on it. See this question. It says in the figure above, ratio of angle ACB. Angle ACB is this angle ACB, this one. And ratio CBA. That means this one. So ratio of this one and this one is given as 3:1. And if angle BCA is 80 degrees. So if the value of angle BCA is 80 degrees, then find the angle Y. So we know if angle ACB is 3x, angle CBA is equals to x. That is angle CBA or BCA. So if angle BCA and so CBA, which is this, and angle ACB, which is this, so ACB or BCA, they both are entirely same. So this is equals to 80 degrees. That means if 3x is equals to 80, then x is equals to 80 over 3. Now, applying angle sum property, that means angle A plus angle B plus angle C should be equals to 180 degrees. So which means 3x plus x plus angle A is equals to 180 degrees. Angle A is equals to 180 minus 4x, and x is 80 by 3. So 180 minus 80 by 3 times 4, which is 180 minus 320 over 3, which on solving will give me 73.3. That means this angle A is 73.3, and they are asking you to calculate y. And by alternate segment theorem, I can say that these two angles are equal. So hence this is equals to y by alternate segment theorem. Okay, so that's it for today. We are done with all the theorems, and we have done just like one question on each type of theorem to get the better clarity. In the next class, we'll do worksheets on circle theorems with some simpler questions, with some harder questions. So that's it for today. Bye everyone. Take care.